Can mathematics be beautiful? We often associate beauty with art, music, and nature, but what about numbers, equations, and theorems? Are they capable of holding a beauty of their own? This intriguing question has sparked an ongoing debate. Let's take a trip back in time to explore the origins of this debate. Albert Einstein, a name synonymous with genius and innovation, once declared that the only physical theories that we are willing to accept are the beautiful ones. He's not alone in this sentiment. Renowned physicist Ernest Rutherford referred to Einstein's theory of relativity as a magnificent work of art. For Wolfgang Pauli, the beauty of general relativity was so profound that it will always remain the pattern of a theory of consummate beauty of the mathematical structure. Fast forward to more recent times, Sean Carroll labeled general relativity as the most beautiful physical theory ever invented. Mathematical physicist Clifford Will went as far as comparing the act of altering general relativity to changing Beethoven's Fifth Symphony. In his view, all alternatives he has seen are horrendously ugly by comparison. Paul Dirac, another great mind, is said to have discovered the anti-electron through his mathematical sense of beauty, even before it was empirically confirmed. His belief in beauty was so strong that he once stated, "It is more important to have beauty in one's equations than to have them fit experiment." He even chastised Schrödinger for not using his mathematical sense of beauty in developing his equation. He stated, if Schrödinger had been more confident of his work, he could have published it some months earlier, and he could have published a more accurate equation. Murray Gell-Mann and Richard Feynman, Nobel Prize winners, also held on to their theory of weak interactions because of their sense of mathematical beauty, even when experimental evidence weighed heavily against it. In spite of the high reputation of the experimentalists, they believed there was something wrong with the experiments, not their beautiful theory. As it turned out, they were right. In 1988, a mathematical intelligencer poll voted Euler's identity as the most beautiful mathematical feat. Euler's identity, a formula that links 5 fundamental mathematical constants, lies at the heart of mathematics, involving 3 basic arithmetic operations: addition, multiplication, and exponentiation. The insurmountable problem for atheistic materialism in all this, besides the fact that mathematics is itself profoundly immaterial in its foundational essence, is that beauty must be subjectively experienced in order to be appreciated. And this necessarily makes beauty a property of qualia, which is defined as individual instances of subjective, conscious experience. And qualia happens to be the central defining attribute of the immaterial mind that has been labeled as the hard problem of consciousness. A hard problem which is held to be forever beyond the scope of any possible reductive materialistic explanations. Moreover, the argument from beauty for God's existence is an ancient one, with St. Augustine stating beauty can be appreciated only by the mind. This would be impossible if this idea of beauty were not found in the mind in a more perfect form. Thomas Aquinas asserted, God is beauty itself. And St. Anselm argued that God must be the supreme beauty for the same reasons that he must be justice, and other such qualities. Of related interest to these ancient arguments, C.S. Lewis, a renowned theologian from the mid-20th century, stated, "We do not want merely to see beauty, though God knows, even that is bounty enough. We want to be united with the beauty we see, to pass into it, to receive it into ourselves, to bathe in it, to become part of it." In conclusion, atheistic materialism, besides failing to explain immaterial mathematics in the first place, fails to explain mathematical beauty since it hinges on our subjective sense of beauty. It is a subjective experience of the immaterial mind that transcends the physical world, pointing to a higher immaterial reality, to God, as the source of this mathematical beauty. In conclusion, that the most foundational equations that describe this universe, namely general relativity and Schrödinger's equation, are described as being beautiful, is a ever so subtle sign that the author of these equations is God.